Hello guys, welcome to this video. My name is Chikujeku Marvelous. Today we are going to be learning about indices and logarithms, and our objectives for today are you should be able to know and apply the laws of indices. Also, you should be able to solve problems, past question papers based on indices. So let's get into the lesson. First of all, we'll start with the laws of indices. The laws of indices. The first thing we're going to talk about here is the concept of powers, where you can have a times a, which you know is when a is raised twice, and a times a times a times a, which is a raised thrice. So the first law, addition law, where you have a to the power of b times a to the power of c is equivalent to a to the power of b plus c. So take note of this law when solving problems. So you add the powers together when the bases are equal. Remember, the bases have to be equal for this law to hold. The bases must be equal. For example, we have a to the power of 2 times a to the power of 5, which is a to the power of 2 plus 5, which is a to the power of 7. So instead of expanding it, you can just apply the law to get the desired result. So now we're going to be looking at the division law. The division or the subtraction law. Division subtraction law, where you have something in the form of a to the power of 5 divide a to the power of 3, and you'll be having a to the power of 5 minus 3. So from the above expression, you can see that when you have a division sign, the two bases are equal. You subtract the powers. That's why we did a to the power of 5 minus 3, which is a to the power of 2, because the denominator a to the power of 3, that is a raised 3 times, to cancel 3 of the a's in a to the power of 5, leaving you with a to the power of 2. So if there is an expression in the form of a to the power of b which divides another expression in the form a to the power of c, where c can be any number, positive or negative, then we have that a to the power of b divided a to the power of c is equal to a to the power of b minus c. Now we are looking at the zero index law of indices. This is talking about when you have an expression of a number raising to the power of 0. Says that any integer, let's say a, when it is raised to 0, it is 1. But there is an exception here. A cannot be 0, meaning that 0 to the power of 0 isn't 1. Is an exception to this rule. I give examples. 1000 to the power of 0 is 1. 3 to the power of 0 is 1. Now, why is a to the power of 0 1? Have you ever asked this question? Why is it that any number raised to 0 is 1? The reason for this is because as a result of two laws. The proof is shown on the screen, where you have a to the power of m divide a raised to the power of m, which is naturally cancelling out to give you 1, because if you have 5 over 5 is 1. But using division law as stated earlier, the powers are to be subtracted. So you have a to the power of m minus m, which is a to the power of 0, which is 1. So take note. Now the fractional index law. This kind of indices applies to those numbers in which their powers are fractions. They apply to numbers which their powers are fractions. For example, if you have a to the power of 1 over 2, in our example I have a to the power of 1 over 2 is equal to the square root of a to the power of 1. How did this come about? So from the above expression, we can deduce that, first of all, we looked at, you take note of the denominators and the numerator. That is, when you are given a number, in this case we have a, the denominator determines the degree of the root. That is why you had root a, because square root is in the root of 2. Then while the numerator is determining what that entire value is raised to, that is the root a raised to 1, the numerator determines that. Please take note. That is, determines the power to which the root is raised. So we are going to take an example where you have 64 raised to the power of 3 over 2 is equal to x, and you are asked to find the value of x. So first of all, you look at the fractional part. Look at the fractional part. What do we observe in the fractional part? The numerator is 3, the denominator is 2. Recall that the denominator determines the degree of the root. Remember the earlier step, d is the determiner of the root, and then the numerator is where it is raised to, and that's why we found the square root of 64, then raise it to 3, we got 512. Let's take another example. Next example 2. Evaluate 16 to the power of 1.5. In this situation, you don't have to be afraid. All you need to do is convert 1.5 to a fraction. On converting 1.5 to a fraction, you have 3 over 2. Then you come back to the fractional index format, where 3 is the numerator, 2 is the denominator. 2 determines the degree of the root. 2 determines the degree of the root. 3 is the power to which it is raised. So for example, we have root 16 to the power of 3 at the end of the day, because the root is 2, raised to the denominator of 3. So you have 4 to the power of 3, which is equal to 64. From all our examples, we have been using 2 as the root. What if the denominator is 3, 4, 5, and so on? All you need to do is to find the third, fourth, or fifth root, as the case may be. For example, if you're asked to find the fifth root of 32, 2 will be the answer, because when 2 is raised 5 times, you have 32. So the next law we are going to look at is the bracket multiplication index, where the powers are enclosed in a bracket. when you have an expression which is in the form a to the power of b to the power of c, the above expression is equivalent to a to the power of b times c. For example, if you have a to the power of 3 to the power of 2, you have a to the power of 3 times a to the power of 3, which is a to the power of 6. The same thing applies to 1 over 3, 6. Then look at equal base law. This law applies when there is an equation where you have two bases that are equal. Now let's consider the expression a to the power of b equals to a to the power of c. The above expression shows that b is equal to c according to the equal base law. So, example 9 to the power of 3 2x equals to 9. So you make 9 to be in base 3. So you equate the powers and then you have x as 1. Negative index law. It applies to numbers in which their powers are negative. For example, 64 to the power of minus 2, a to the power of minus 2. The example given below, a to the power of minus 2 is equal to 1 over a to the power of 2. So the above expression is telling you that the values of a number with a negative index or negative power is the reciprocal of the value without a negative power. That's why you had a to the power of minus 2, 1 over a to the power of 2. So example, when you have 2a minus to the power of minus 1, you still apply that law. So the practice question, solve this on your own and see whether you can apply them to solve problems. With all the laws given, you should be able to solve these problems and come up with answers. Quality answers. So the answers to these questions will be on part 2 of this video. So you check whether your answers are correct. So do well to subscribe to my channel. Thank you.